ethene to ethane, and then from ethine to ethene to ethane. So we could prepare alkanes by using unsaturated hydrocarbons. Unsaturated hydrocarbons meaning alkene and alkanes. So we used alkene and alkanes to prepare what? The alkanes. Okay. So that we did. Then we did with haloalkanes. So by adding two nascent hydrogen, if you see what we have done yesterday, by adding two nascent hydrogens to alkene, sorry, two nascent hydrogen to haloalkane, we got what? Bolo, what did we get? We got alkane, right? देखो ऐसा यहाँ पे I'm talking about this reaction. So this was the structure. CH3Cl, then we added two nascent hydrogens. Two nascent hydrogens we can write like this. One H and one Cl combined to form HCl. And then the other H will get attached over here forming CH4. So we prepared what? Alkane. Which alkane we prepared over here? Like that we can prepare a number of, like that we can prepare a number of. Yes or no? Yeah. Then another method with haloalkane was with the help of sodium, if you remember. Yeah, and this is called as Wood's reaction. U and U connected to form a W. I told you mnemonic yesterday. U and U connected to form a W. So W is CH3, that is ethane, in presence of dry ether. This Wood's reaction. This reaction was the limitation. The limitation was that we cannot prepare alkanes containing, we cannot prepare alkanes containing odd number of, we cannot prepare alkanes containing odd number of carbons. We cannot prepare alkanes containing odd number of carbons. That was the limitation which was given to us in Wood's reaction. Okay, so ये हो गया. अब after that we did a series of reactions which were very similar to Wood's reaction. Okay, which were those reactions? Which were those reactions? One was Franklin. In place of sodium, if I use zinc, it's Franklin reaction. This is Wood's reaction. Then in place of sodium, if I use zinc, it becomes Franklin. If I use copper, it becomes Ullmann reaction. And in place of CH3, if I use a benzene ring or a phenyl ring, then it will get biphenyl, and that's called as a Fittig reaction. So these are the series of reactions which we did for preparation of alkanes yesterday. Okay, now let us continue with a few more reactions today. So have a look over here. CH3, C double bond O, ONA. CH3, C double bond O, ONA. This is what? This is your sodium acetate. Sodium acetate. Okay, so sodium acetate. How do we? So how has this sodium acetate come into existence? It has come into existence because of acetic acid. So we reacted basically acid and base reactions. You know, this is an acetic acid, molecule of acetic acid. You know what is acid and base? पढ़ा है ना 10th में. Acids and bases react to give salt and water, है ना? So acids and bases react to give salt and water. So this two acetic acid, 2 moles of acetic acid, 2 moles of Na. What will happen? Acids and bases react with salt and water. So what will happen? H will get removed. Acids and bases react with salt and water, but acids and alkali metals react with salt and hydrogen gas. So that's what is going to happen. We're going to get salt and hydrogen gas. Which salt we are going to get? Sodium acetate, CH3, C double bond O, ONA. Okay, plus H2. This will be 2. So here we get sodium acetate. Am I preparing alkanes over here? Have I prepared alkanes over here? Yeah, tell me. Am I preparing alkanes over here? बोलो ना. Alkane का preparation चल रहा है क्या ये? Hello.
Yes.
Are you dead or alive? All of y'all, please respond.
Yes, sir.
Yeah. What about the others? Hi there. Are you understanding? Irisha, Krish, Roshan,
Yes, sir.
Sharvari, Soham,
Yes, sir.
Umaima, Vedashri.
Yes, sir.
Yeah.
Yes.
Yes. So this is acid and metal. We are not preparing alkanes as of now. Alkanes I'm going to prepare from here, but just I wanted to show you कि reactant आया कहाँ से भाई? कोई reactant आया यहाँ से. When I react metal gas, I get sodium acetate. So I just wanted to show you from where this sodium acetate has come. So I've shown it to you. Now I'm going to do NaOH in presence of, I'm going to react NaOH in presence of CaO and in presence of dry distillation. Okay. Now NaOH and CaO, this combination together, okay, this combination together is called as soda lime. From where has this name come? This name has come because these two have been fused. Because इसका नाम है caustic soda, या caustic soda, और इसका नाम है quick lime. Yeah, hello. So sodium hydroxide is caustic soda and CaO is quick lime. So caustic soda and quick lime, ये दोनों caustic soda में से soda word उठाया, quick lime में से lime word उठाया, because we are fusing these two, so it's soda lime. Now this combination is called a soda lime. Soda lime and dry distillation. Whenever we use soda lime and dry distillation, it is a step down reaction. What do you mean by step down reaction? Yes, anybody? Step down reaction. Soham, what is the meaning of step down reaction? Yes, Soham, what is the meaning of step down reaction? अब टाइप मत करते बैठ, जल्दी से अनम्यूट कर. या टिल सोहम, या सोहम, चलो जल्दी. क्या बोल रहा, सुनाई नहीं दे रहा कुछ भी, खाली खाना खाने की आवाज आ रही. खाना खा रहा क्या बेटा? पार्क के जैसा हो गया क्या? क्लास में बैठ के खाना खा रहा, सो रहा. So we'll ask Roshan. Roshan, what is the meaning of step down reaction?
So I don't know, sir.
Yeah. So yesterday's Woods reaction, if you saw, if you have seen, yeah, no, we can't hear you so. Okay. So yesterday's Woods reaction, which we had seen, was, where is that Woods reaction? Yeah, here was a step up reaction. Why is it called a step up? By basic step up and step down. So step up meaning reactant में एक कार्बन था, मतलब सिंगल कार्बन वाला था, बट वो दोनों कार्बन कनेक्ट होकर number of carbons the product has promoted, okay, from chloromethane to ethane. So methane का ethane हो रहा है, ethane का butane होगा, butane का octane होगा. So the number of carbons in the product are getting connected, they are increasing, the chain carbon chain length is increasing. So that is called as a step up reaction. और स्टेप डाउन रिएक्शन क्या है कि नंबर ऑफ कार्बन डिक्रीज. हाउ मेनी कार्बन आर हियर? 2 कार्बन आर हियर, बट जो अल्केन हमको मिलने वाला है वो 1 कार्बन का मिलने वाला है. तो इट्स स्टेप डाउन रिएक्शन. आर यू अंडरस्टैंडिंग? स्टेप अप एंड स्टेप डाउन. हेलो
Yes, sir.
Irisha, are you understanding step up and step down?
Yes, sir.
Yeah, so I'll just erase this part. So this step down reaction will always occur. मतलब अगर आपको एरो पे ये दिखाई देता है, NaOH and CO दिखाई देता है, ये कॉम्बिनेशन दिखाई देता है सोडा लाइन का along with dry distillation. So you have to understand, what you have to understand, that this is going to be a step down reaction. Okay, this is going to be a step down reaction. Let's see how that step down takes place. So the step down will take place like this: Na, Na, Na2. Pay attention. Na, Na, Na2. Okay, then CO1, O2, O3, Na2, CO3. Samjhing? Na2, CO3, Na, Na, Na2, CO1, O2, O3, Na2, CO3. Hello, are you understanding this? Na2,
Yes, sir.
CO3.
Yes, sir.
Yeah. Then are you remaining with this hydrogen? Have you utilized this hydrogen? No, we haven't utilized this hydrogen yet. So we'll combine this hydrogen with the CH3, and what we'll get? We'll get methane. What we'll get? We'll get methane. So our aim was to prepare alkenes, and we have prepared an alkene. Which alkene we have prepared? Methane. Now, can you see that methane is a one carbon alkane, and here in sodium acetate we were having two carbons. The alkane which we are getting is with only one carbon. So what is the problem? It's a step down reaction. Here there were two carbons on LHS, and here in the product, in the major product, we are having just one carbon. So it's a step down reaction. What it is? It is a step down reaction. Are you understanding this step up and step down?
Yes, sir.
Yeah, step up and step down reaction. Step up when the number of carbons in the product increase. Step down when the number of carbons in the product decrease. That is a step up and step down reaction. Okay, so this is another method by which we prepare alkenes. Now you have to do, you have to do, you have to prepare propane using the same reaction. Come on, use whatever reactant you want. You have the liberty to choose your own reactant. And but the product which is formed should be propane. Instead of methane here, you should get propane. Do whatever you want, get propane over here. Yes, I will prepare propane.
Just a second, sir.
Yeah, and what about the others? Irisha, are you done? Umema, are you done? Umema, how was your paper?
So good.
And what about Vedashri, Sharvari? You all did not tell me. How was your paper?
It was nice, sir.
Nice, sir.
Yeah. Yes, anybody who's got the answer? Risha, did you get the answer?
Sir, we use sodium butanoate and we react it with NaOH to get Na2CO3 and propane.
Good, very good. So sodium butanoate. Now, most of the children, what mistake they do is they take 3 carbons over here. Okay. See, it's a step down reaction. Take 1 carbon extra over here. So if you want propane, which is of 3 carbons, make sure you use 1, 2, 3, 4 over here. Some children, what mistake they do, they don't consider this as a carbon. This is very much a carbon. It's a carbonyl carbon. Okay, so inclusive of this carbon, there should be a total of 4 carbons if you want a 3 carbon alkane. So if you want to form a 5 carbon alkane, that's a pentane. Okay, if you want to form pentane, then make sure you use 6 carbons over here in total. Are you understanding what I'm trying to tell you? See, because it's a step down reaction, it's going to decrease by 1 carbon. So if you want to prepare pentane, make sure you use 6 carbons over here. If you want to prepare propane, you will be using 4 carbons over here, like Irisha has rightly told us. Okay, we'll be using 4 carbons over here. The remaining story is same: CaO, dry distillation. Okay, then Na2CO3. How many of you have not got this? We're not able to do it. Such a simple one. Hello. Just a second. Now, this is not only this much. This is going to combine from here to here. Na2CO3. Yeah. So how many of you have not understood or did not get it? Yeah. Hello.
And now I understood.
Now you understood, but before you were not able to do it on your own, Dhruv.
No, sir, I wasn't.
Okay. Thank you for being honest. Yeah. Then what about the others? Hi there. Were you able to do it? Hi there, Soham. Umayma, Vedashri, Roshan, were you able to do it on your own?
Yes, sir.
Yes, sir.
Good. Good. Chalo. Next. Now let's go to the PPT where we were yesterday. So we were here. We did food synthesis yesterday. Woods reaction. Then after that, Woods reaction we have finished yesterday. And all associated reactions also we have done. Come on, answer this question. Yeah. C2H5Cl in Woods reaction gives. What will this give? C2H5Cl in Woods reaction will be what? Come on. What is it going to give?
Sir, ethane.
What will be the product? And how come ethane? Kya kar raha bhai? Pay attention. C2H5Cl. Now, although they have not mentioned C2H5Cl is taken twice, but you have to understand that if it's Woods reaction, it is going to be twice. C2H5Cl and C2H5Cl. Then 2Na and 2Cl will combine to form 2NaCl. I hope you're able to see this. Yeah, 2Na and 2Cl will combine to form 2NaCl. And then you remember that this was U, this was U and U connected to form a W. So C2H5 along with C2H5, it becomes a total of 4 carbons, or you can write CH3, CH2, CH2, CH3 also. It's going to become what? Butane. So we're going to get, what should be the answer? The answer should be butane. Yes, ladies and gentlemen, are you getting this?
Yes, sir.
Yes.
Yeah. So your answer has to be butane. Okay, so those who have joined, especially Hatching guys, you all were not there for when your exams were going on. So we have not done much. We've just started with hydrocarbons. Okay. We had given a few days. I mean, I had not taken a session for a couple of days in between. We had practice sessions twice. Okay. Then come on. propine under hydrogenation will give you. If you hydrogenate propine. Now, what do you mean by hydrogenation? Yeah, anybody? What is the meaning of hydrogenation? Hydrogenation meaning addition of hydrogens. If you add hydrogens to propine, what are you supposed to get? Hello, what are you supposed to get when you add hydrogens to propine? अब ये भी बताना पड़ेगा क्या? Hello.
So propane.
Yes, you will get what? Propane. Come on, preparation of alkenes part 3. Now further we have to prepare alkenes. This is what we have done, decarboxylation of fatty acid. Okay, that step down reaction was called as decarboxylation reaction. This is what we did. Do you remember? Just now on the green board, Na2CO3. So we removed CO2. So because we removed CO2 from here, it's called as decarboxylation. Sir, वो आपने ऐसा नहीं लिखा था. अरे भाई, मैंने जो लिखा था, that was C double bond O. C double bond O. One oxygen had written like this, and one oxygen had connected directly. So this is also right, and our writing RCOONA, that is also right. Both are right. Both are giving you alkanes. Alkanes plus Na2CO3. So NaOH and CO together, it's called as soda lime. And this is dry distillation. Remember the ratio of NaOH and CO. It should be in the combination of 3:1. Getting it? This is the reaction which we have just done, and you all have practiced also. You all were struggling to prepare butane. Prepare propane from sodium butanoate. Correct? Got it till here?
Yes, sir.
Yeah. Come on, next. Yeah. Can you tell me the product? What's going to be the product? We're going to perform dry distillation for this. Dry distillation and perform decarboxylation. What are we going to get? We've done this reaction a few seconds ago. Yeah, what are we going to get? Hello?
Methane.
Yes. We'll be getting methane. Okay. And here in the second case, what will we get? Sharvari, please answer. Sharvari, please answer. What will we get?
Yes, sir.
Yes, sir. Are you getting up from sleep? Answer this. What will you get? In the second reaction, what will be your product? Sharvari,
Sure.
what?
I'm not sure.
No problem. Just give me your answer, even if you're not sure. Just give your answer. Yes, Sharvari. Waiting for your answer.
Yes, sir. I'm not sure.
It's okay if you're not sure, I'm telling you. You give the wrong answer, I'll accept it. But don't keep quiet like this. Please give the answer. Even if it's wrong, it's okay. Hi there. Hi there. Hi there. Hi there. Please respond.
So ethane.
Yes, the answer will be ethane. Okay. Come on. Now, next is from carboxylic acid by coal-based electrolysis. Okay, come on, write this down. This is called as coal-based electrolysis. Yes, even Hachin guys, even you all write down. We have not done this in school, so please write down this coal-based electrolysis. Yes, have you written down? Yeah, have you written this down? Hello.
Yes, sir.
Yes, sir.
Yeah. So now, if you can see over here, in this reaction, we have again used sodium acetate, like we had used in the first case, sodium acetate. Then after using sodium acetate, we are going to perform electrolysis. And for performing electrolysis, we need it to ionize, to dissociate, to convert into ions. So we add water, and once it dissociates, the Na plus will now combine with OH minus from water. Okay, because water is also going to dissociate into H plus and OH minus. Okay, so if you want, I'll show it to you like this. Check. Okay, so H2O is dissociating into H plus and OH minus. So as we are having 2H2O over here, we'll get 2H plus and 2OH minus. So we have taken this also as 2. Okay, we have taken this also as 2. So we are having 2Na and 2OH will combine to form 2NaOH. 2Na and 2OH will combine to form 2NaOH. Then this CO2, this is also 2. Now this structure is 2. It's written twice. So CO2 will be released. 2 CO2 will be released. Then this H and H, let them combine to form H2. Let them be released as hydrogen. And then this CH3 and CH3, there are 2 CH3 over here. So CH3 and CH3, let them combine with each other to form what? Ethane. To form what? Ethane. Getting it? Hello?
Yes, sir.
Yeah.
Yeah. So this is coal-based electrolysis. Okay, coal-based electrolysis. I hope you have understood. Should I explain it once again? Yes, Soham, hi there. Roshan, should I explain it once again?
No, sir.
Okay, even you are telling no, but still I'll explain it once again. You know why? Because some people are hesitant to ask for repetition. Okay, don't hesitate if you want me to repeat. Okay, I'll repeat it once again. Pay attention, because maybe it's online. I don't know what you all are doing. If you all are not paid attention, you wouldn't have understood this. So I'll repeat once again. We are having 2H2O, 2H2 will split into 2H minus, 2H minus. Why? 2H plus and 2H minus, because we are performing electrolysis. Electrolysis is going to make it dissociate. Here, I'll write this as CH3COONA because it is 2, right? So maybe if you're not understanding, instead of writing this 2, I've actually written it twice, 2 times. Okay, so 2Na and 2OH. Now I think you should understand better. 2Na and 2OH. Okay, 2Na from here and 2OH from here will combine to form 2NaOH. Okay, then this CO2 and this CO2 is also decarboxylation. So you give you 2 CO2. Then these 2 hydrogens will combine, H and H will combine to form H2. And we are having 2 CH3 over here. These 2 CH3 will combine to form ethane. And that is what we want. That's the major product. That is alkane. I hope you have understood much better now.
Yes, sir.
Yes, sir.
Yeah. So this is coal-based electrolysis. Okay, coal-based electrolysis. Okay. Yeah. This thing you are getting at anode, this thing you are getting at cathode. Okay, no need to do the mechanism. Additional information, have a look. Okay, so this is Grignard reagent, the preparation of alkanes from Grignard reagent. So I haven't told you what is a Grignard reagent yet. We'll do from this slide, we'll do tomorrow. Okay, preparation of alkanes using Grignard. What is Grignard reagent? And I'm going to give you 2 more extra reactions which are not here, which are not there in your textbook also. That is Clemenson's reduction and Wolff-Kishner reduction. Clemenson's reduction and Wolff-Kishner reduction are 2 extra reactions which I'm going to give you. That will again be tomorrow. And with Grignard's reagent also I'll give you tomorrow. Is that okay?
Yes, sir.
Yeah. So till then, good evening and thank you all of you.
Good evening and thank you, sir.
Yes, and please be regular. All of you, please be regular to class. Okay, please be regular to class.
Yes.
Okay, good evening and thank you once again. Fine.